this is Diana, and this is a pre-recorded video created for the sole purpose of showing you how we can convert decimal into binary. So before taking up this entire conversion process, let us first get to know the concept of number systems. Number systems are systems in mathematics that are used to express numbers in various forms and are understood by computers. There are a variety of number systems that have different properties like the binary number system, octal number system, decimal number system, and hexadecimal number system. So let's take a sneak peek on what these systems exactly are pertaining to. And let's start with the binary number system. The binary system is a base 2 system which is only two digits that are 0 and 1. Each number or value is represented by zeros and ones, 0 being an off state and 1 being an on state. Next, we have the octal number system, which is a base 8 system that has only 8 digits from 0 to 7. Each number or value is represented with 0, 1, 2, 3, 4, 5, 6, 7. And we also have the decimal number system, which is a base 10 system that has only 10 digits from 0 to 9. Each number or value is represented with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then there is hexadecimal number system, which is a base 16 system that has 16 alphanumeric values from 0 to 9 and A to F. Each number or value is represented with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F, wherein A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Now let's move on to number system conversions. And now, at this juncture, we will study to convert a number of one base to a number of another base, since number system conversions deal with the operations to change the base of the numbers. We can also perform different arithmetic operations such as addition, subtraction, and multiplication on number systems. Nonetheless, as we go back to this video's main focus, which lies on one out of the many conversions we have, specifically the decimal to binary, let us take this time to finally dig deep to the conversion process. So in order for decimal to binary conversion to take place, we have different steps for us to follow. Step 1 would be to divide the given decimal number by 2, where it gives the result along with the remainder. Step 2, if the given decimal number is even, then the result will be whole and it gives the remainder 0. Step number 3, however, if the given decimal number is odd, then the result is not divided properly and it gives the remainder, which is 1. Step number 4, by placing all the remainders in order in such a way, the least significant bit at the top and the most significant bit at the bottom, the required binary number will be obtained. So in order for us to fully comprehend this entire conversion process, let us finally take it into application using the following example. So here we have 294 base 10, which is a decimal number, and we're going to have to convert it into binary. And in order for us to do so, we take the decimal number, which is 294, and divide it by 2. This then gives us the value, which is 147. And since 294 is an even number, when divided by 2, it was able to generate a quotient that is exact value having no remainder. That is why we put the value of the remainder as 0. Next step, we'll have to take the integer quotient, which is the 147, as our new dividend, and once again divide it into 2. This will then give us a value that is 73 point something. And since 147 is an odd number, and as we divide it by 2, it was able to generate a quotient that has a remainder, and we'll put 1 as the value of its remainder. This process of taking the integer quotient and making it as a new dividend, and once again dividing it by 2, as well as obtaining its remainder value, goes on and is continually performed until the quotient finally reaches to 0. And once it reaches to 0, the execution of the division process will be terminated. So we now have these values, wherein the bottom part is called the MSB, or the most significant bit, and the top part is considered as the least significant bit. It is also of great importance to take note that the MSB is situated on the far left end of a binary value, while the least significant bit is situated on the far right end of the binary value. This information would be relevant as we proceed on the next step, which is arranging the remainders in a reverse chronological order. And as we do so, we obtain 100100110 base 2, which is the binary equivalent of our given decimal number. So now we finally have the equivalent binary value of our decimal number, which is 294 base 10. And if in case we wanted to check if 100100110 base 2 is the correct binary value of the given decimal number, we can check if our conversion process has been done accurately and successfully. In order for us to do so, we take the binary value and apply the binary rule, which is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. Then we have to take the values of the on-state ones, which is 2 to the power of 1, 2 to the power of 2, 2 to the power of 5, and 2 to the power of 8. And this will then equal to 2, 4, 32, and 256. Now it's time to take the sum of these values and check whether it corresponds to the decimal number. We obtain 294. Since it corresponds to the given decimal value, hence we can conclude that the entire conversion process is done successfully and accurately. So that's it for the decimal to binary conversion, and I hope that this video was able to serve its purpose. Thank you for watching.